Students, now today in class 9th I am taking the numerical of the chapter 5C of 9th class and that is the floatation, numerical based on floatation. 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 Now the first numerical. The numerical is here: a rubber ball floats on water. A rubber ball floats on water with its 1/3 volume. With its 1/3 volume outside water. Outside water. What is the density of rubber? Now it is asked that what is the density of water? This is now question. Now solution to this one is, now 1/3 part is outside the water. It means that 2/3 of its volume will be inside the water. The volume of ball inside the water is 2/3 of its volume. So let this is now your 2/3 into V. V the volume of the ball. So weight of ball is equal to weight of water displaced. So weight of ball, now volume is given to be now so much and the density of this ball and the density is 2/3 of rho. Now this mass is given to be, now this volume is B and its density is given to be, now this is now your rho into G equal to, this is now your 2/3 into V into the density of water is to be now 1, or this is to be taken in kilograms, 1000, that is into G. So now we have to find the density rho and this will be cancelled by this G will cancel by this one. So density rho is equal to, what is the density of rubber? Rho is equal to 2000 upon 3. So this will be over 368, then 366.67. So much kilogram per meter cube. Or we can write it to be, now if suppose we leave to this 0.66, then we can write it to be 667 kilogram per meter cube. So this is the answer to this question number 1. Now then question number 2. Now question number 2 is a block of wood of mass 24 kg. A block of wood of mass 24 kg floats on water. Floats on water. The volume of the wood is, the volume of wood is, this is given to be 0.032 meter cube. Now we have to find number 1, the volume of the wood, below the surface of water, below the surface of water, and second, the density of wood. The density of wood. This is given in the question. So now the solution is that this is the piece of wood. This is now wood. This is floating in the water. This is now like this. This is now water. This is wooden block. And now we have to find this volume, that how much is this volume? This is the volume. That is the, suppose this now volume is V. Here we take the volume, it to be now V. This is not so much volume. So now first one, the V rho into sigma is equal to V sigma into G. Now this is the weight of the wooden block. This is the weight of the water displaced. Or we write down it like this one. Weight of wood block equal to weight of water displaced. So this is now your V rho into G equal to V sigma into G. Now we are given this, now this B is given so much, 0.032 rho, the density of the boat, will be equal to mass upon volume. So mass is given to be 24 and this is now 0.032 into, now this G will cancel from both sides and this is equal to now V and this sigma, this is given to be now 1000. So now from here this V is coming, now this term will be cancelled by this one. So this V is equal to 24 upon 1000. So this is now 24 into 10 raised to the power minus 3 meter cube. Or this is to be, if we write on this, eliminate to this now, then 0.024 meter cube. So much volume will be inside this water. Now then second, this is the answer to the first question. And now second, the density rho equal to m upon b. Now this m is equal to 24 and b is equal to 0.032. So if you do it, then this rho is equal to 24 upon 32 into 10 raised to the power 3. Now this 3 zeros will be here and 8 4 and 8 3. So this rho will be 0.75 into 10 raised to the power 3. Or we can write it to be this rho equal to this, we eliminate, then this is now 750 kilogram per meter cube. This is the answer of the second part. So we simply apply the law of rotation, that the weight of the wooden block equal to the weight of the water displaced. Now the question number 3. Now question number 3 is a wooden cube of side 10 centimeter. A wooden cube of side 10 centimeter. Has mass 700 grams. Has mass 700 grams. 700 grams. What part of its volume is of the surface? This is now what part of its volume? What part of its volume of it remains that above the water surface, above the water surface, while floating vertically, vertically on the water surface. surface. This is the question. So now let its solution is this is the block of water. This block of wood like this. This is now block, and let this is so much. This is now wood, and let this is now height h here. That is inside the, and this whole of the height is given to be now 10 centimeter. Whole of the height is 10 centimeter. This height is 10 centimeter. Then again we are having the weight of log is equal to weight of water displaced. Here all things are given in this CGS system. So now volume of this V rho into G equal to V. This is now your small v into sigma into G. Sigma the density of the water. So now this is equal to A into total height. A is the area of cross section into the height. This is now 10 centimeter, and this is now the density is given to be here. Density of block. We are giving the weight 700, and this we are giving the 10 centimeter. So the volume will be 1000 centimeter. So this is now your 700 upon 10 into 10 into 10. This is the volume of the block, and this G will cancel, equal to V the volume. This is now A into inside this one. This is now suppose this is H. So H, and this is equal to 1. So now you can have now then this 3 zeros will cancel from here. This A and A will cancel from here. So this H is equal to centimeter. So inside the water it must be 7 centimeter. Inside. This is now then floating vertically on the water. How much above the water surface? Above the water surface. Above water surface. This is now your 10 minus 7 equal to 3 centimeter. So this height will be 3 centimeter. So this is being asked that what is the height, its part that is above the water surface. So this is inside, this is inside. Inside we are having so much, and outside will be so much. Now question number 4. Question number 4, a piece of wax. A piece of wax floats on brine. Floats on brine. Floats on brine. What fraction of its volume is immersed? What fraction of its volume is immersed? Now you are given the density of wax equal to density of wax. Now density of wax is 0.95 gram per centimeter cube, and density of brine. Density of brine is 1.1 gram per centimeter. So now we can have that weight of wax equal to weight of brine displaced. So this is now V rho into G equal to V sigma into G. So now G will cancel, and V. This rho is given to be here, wax 0.95. This is now V into, this is given now 1.1. So therefore V upon V. This is now 0.95 upon 1.1. So just you cancel to this one by this, just you divide to this one by 1.1. Then this will be density of So just you remove this decimals. So this is your 95 upon 11 into 10. Then this will come out to be this 8 point. This is now approximately 8.6. 8.6. This will come out to be 8.6. So this now this V upon V is equal to, this is now 0.86. This is not so much. This is now answer. You have to find the fraction. This so much of its volume will be immersed in the brine. Now question number 5. If the density of ice is 0.9, if density of ice is 0.9 gram per centimeter cube, what portion of an iceberg? What portion? No. What portion of iceberg will remain below the surface? Will remain below the surface. Below the surface in a sea. In a sea, this is now. And given the density of seawater, density of seawater, this is equal to 1.1 gram per centimeter cube. So now again we have the solution to this one, that is the weight of iceberg equal to weight of seawater displaced. So weight of iceberg, this is given to you now. तो फ्रैक्शन कौन सा रहेगा, व्हाट पोर्शन, दिस इज नाउ v rho into g equal to v sigma into g and g will cancel. Now be the volume of the iceberg. Be the volume of the iceberg, and this density is given to be 0.9 is equal to V into the density of seawater. This is now 1.1. So V upon V, this is equal to 0.9 upon 1.1. This is so much, and these points will be cancelled from here. So this will come out to be 9 by 11. 9 by 11. So much. This is the answer. And now question number 6. Question number 6 is a piece of wood of uniform cross-section area. A piece of wood of uniform cross section area, and height of 15 centimeter and height of 15 centimeter, floats vertically with its height, floats vertically with its height 10 centimeter in water, height 10 centimeter in water, 10 centimeter in water, and 12 centimeter in a sprit, and 12 centimeter in a sprit. Find the density of wood and sprit. Find the density of number 1 wood and number 2 the sprit. Now then we are coming to the solution. First, weight of wood equal to weight of what? Weight of water displaced The same formula is to be used. V rho into G equal to V sigma into G. G and G will cancel. So now V is equal to A into the height is 15 centimeter. This is now 15 centimeter. This will give you the volume, and its density. The density of wood. This is now 1 centimeter. Density of wood दी गई होगी. अच्छा, the density तो निकाल लिया. Find the density of wood. This is now into rho, and this is now A into, now inside this water, this is now 10 centimeter. So 10, and this is now what is given in CGS. So this is now equal to 1. Then this height is given to be now 15 centimeter. 15 centimeter. So this A will cancel from both. So this rho is equal to 10 upon 15. This is now your 2 by 3. So this density, that is now 2 by 3. Or rho is equal to 0.666 gram per centimeter cube. So this is now 1 more 6. So this is now 0.667 gram per centimeter cube. This is the answer to the first question. Then now in the second, weight of wood equal to weight of spirit displaced. So this is now your A into this A rho in, this is now V rho into G equal to V sigma into, now G will cancel. So this is now your A into 15, and this rho is 2 by 3. Here we have known to this one. This is not 2 by 3 equal to V, the volume. So this is now A into, and the spread, this is in 12 centimeter. Height is 12 centimeter in spread. Here this one 12, and sigma you have to find. A and A will cancel. So therefore this sigma is equal to, this is now your 30 upon 3 into 12. 3 to this is now your 10, and 2 to 6, 2 to this is now your 5. So this sigma equal to 5 upon 6. So 0.68 is 48, and 2 6 3 is then 6 3 is so much gram per centimeter cube. This is now question number 6. Come on. Sixth question. This is 15, this is now your 2 by 3, and this is now 12 centimeter, so 30, 3 into 12, so this is now your 30 is a 3 by 10, then this is 8 and 2, 0.8, ठीक है सही है, 833, this is the right one. Now similar is with this question 7, and this is now question number 8, and now I am taking the question number 9. which is more typical to one. Question number 9. You are given that a water forecasting plastic balloon, a weather forecasting plastic balloon of volume 15 meter cube contains hydrogen of density density 0.09 kilogram per meter cube. The volume of an equipment, the volume of an equipment carried by balloon is of negligible. Is of negligible compared negligible compared to its own volume. Compared to its own value, to its own volume. The mass of the empty balloon, the mass of empty balloon alone is 7.15 kilogram. The balloon is floating in the balloon is floating in air. Floating in air of density 1.3 kilogram per meter cube. Calculate the mass of the hydrogen. Calculate number 1, mass of hydrogen in balloon. Second, the mass of hydrogen in balloon. Mass of hydrogen and balloon. Third, total mass of hydrogen balloon and equipment. Total mass of hydrogen balloon and equipment if mass of equipment is x kg. If mass of equipment is x kg. And now fourth is asking the mass of the air displaced by the balloon. Mass of air displaced by balloon. And fifth is the mass of equipment. Mass of equipment using law of rotation. Using law of rotation. Law of rotation. This is the question. Now then solution to this one. The question is large one. First the mass of the volume of the hydrogen. So this volume of the hydrogen is given to here, and the mass, the density is given to be here. So this the mass of hydrogen. First mass of hydrogen. M equal to D into V. This is so this M equal to D, the density. This is now 0.09 into V, that is your 15. So 15 9 is 35, 135. So this is now 1.35. So much kilogram is the mass of hydrogen. And now second, it is asking that mass of hydrogen plus balloon. Mass of hydrogen and balloon. Now this will be equal to the mass of these this is given to you. The mass of empty balloon is so much, 7.1.5, and this is now 1.35. So this is 5, 5, 10, 40, and this is now your 8.50. 8.50. Or this is now 8.5. So much kilogram. And then the third part. Total mass is equal to 8.5 plus x. So much kilogram. X the mass of the equipment. And now fourth is the mass of the displaced air. So mass of displaced air. It will displace the volume equal to the volume of this balloon. So this is now given, the volume of the balloon is 15, and that the density of air is given to be 1.3. So this is now your 1.3 into 15 mass, volume into density. So 15 3 are 45, 4, 15 and 4 19. So now after this one, this so much is the mass of the air displaced. Mass of the air displaced 19.5. And then the fifth to this one, fifth is the mass of the equipment. So weight of total weight, we can say that total weight is equal to the weight of air displaced. So this will total is to be your this 8.5 plus x into g is equal to this the density, the mass of the air is given to be so much. This is your 19.5 into g. And this g and g will cancel from both sides. So x equal to 19 minus 8.5. So 8, this is now 11, so it's now 10.5. 10. This is now 11 kg. Oh, this is 19.5. 19.5 minus 8.5. So this is now your 11 kg. This. So thus I have solved a number of numericals, but some of them are left. For that you practice at home and do the practical or do all these numericals. So this is about the numerical of based on the flotation for the class 9th. Thank you very much.